Assalamu alaikum warahmatullahi wabarakatuh, dear students. Welcome to my channel. As I have already told you that I have started video lectures on mathematics for class 8th. And in the first video, in the yesterday's video, I have told you about the polygons. Today, I am going to repeat all the content that I have delivered yesterday in a very short time. The last video, I think that was a bit long, and today I will try to keep my video short and to the point. Okay, without wasting time, let's start. So, what are quadrilaterals? So before understanding quadrilateral, we must have knowledge about polygons. Okay, so what is a polygon? A polygon, all the figures that you see on screen, these are polygons. So how can we define a polygon? A polygon, it is a simple closed curve made up of only line segments. Okay, as you can see on screen, the curves that are polygons. Why they are polygons? I'll explain to you. So this one, it is a simple curve. Simple curve means if I am able to draw a curve on plane surface without lifting my pen, or without retracing a part of it. There is no retracing, no overlapping of lines. It is a simple curve and it's closed. That's why it is a polygon. And this one, it is also simple closed curve. It is also a polygon. And here, this is also a simple curve without overlapping of lines, and it's closed, and it is also a polygon. So these three curves, they are not polygons. Why they are not polygons? Because in first case, it is a simple curve. No doubt it's a simple curve, but it is not closed curve. When it's not closed, that means it is not a polygon. Okay, this one, this curve is not simple because here we have overlapping of lines. These two lines are overlapping, and it is not a simple curve. When it is not a simple curve, then it is not a polygon. No doubt it is closed. And this one, it is also a simple curve, but it is not closed. That's why it is not a polygon. Okay, hope you have got it. Okay, now the classification of polygons. The polygons start from three sides because a curve that is only one line segment. It's not that cannot be closed. Two line segments cannot be closed. So the polygon starts from three lines. Here, a polygon with three sides. And make sure the polygon. If I will tell you one more thing. If I will draw this line segment here, and I will draw another curve like this. It is also simple. It is also closed. It is a simple closed curve, but it is not made up of only line segments. This is a line segment, but here it is a curvature. So we can say this is not a polygon. Okay. Now here, this one, simple closed figure of three line segments is called a triangle, and this one, four sides, it is called a quadrilateral. A polygon with five sides is called pentagon. A polygon with six sides is called hexagon. Similarly, seven sides, heptagon, eight sides, octagon, nine sides, nonagon, and 10 sides, decagon. Okay. Now, what is a diagonal? We can draw diagonals on any polygon except triangle. I will tell you why we can't draw a diagonal on a triangle. So first of all, we will look at this figure. Here I have a B, C, D, a quadrilateral, or we can say a four side polygon. A diagonal, it is a line segment connecting two non-consecutive vertices. What is this vertex? This is a vertex A, this is vertex B, and this is vertex C, vertex D. So what are non-consecutive or non-adjacent vertices? Non-consecutive vertices, before going to teach non-consecutive, let's see what are the consecutive and what are the adjacent. So here we can see the vertex A, it is directly connected with D and it is directly connected with B. So these two, A and D, are the adjacent vertices for vertex A. And with C, C is not directly connected with A. So this is called the non-consecutive vertex of A. So when we look at the diagonal, definition, a diagonal, it is a line segment connecting two non-consecutive vertices of a polygon. So here, when we when we draw a line segment from A to C, so this will become a diagonal. Here, for B, it is directly connected with A, directly connected with C. That means A and C, they are the adjacent vertices for B. And D, that is a non-adjacent, or we can say non-consecutive vertex. So when we connect B and D, it will also become a diagonal. So in a quadrilateral, we can draw at most only two diagonals. Okay. So if we talk about the triangle, can we draw a diagonal for a triangle? Let me draw a triangle here. If it is a triangle, this is a vertex A, vertex B, and vertex C. Here, A, it is directly connected to B and C. A have no non-adjacent this vertex. B also have no non-adjacent vertex, and C, here C, it have no non-adjacent or non-consecutive vertices. So that is why we can't draw a diagonal on this triangle. Okay. After that, another classification of polygon, regular and irregular polygon. So what is a regular polygon? A regular polygon has all sides and angles equal. So this is a polygon, it's a pentagon. Here, this side, this side, this side, this one, and this one, they are all equal. And here, this side is equal to this side. This is a square, all sides are equal. A polygon with all sides and angles equal is called a regular polygon, because when all sides are equal, all angles are also equal. We can say a regular polygon is equilateral as well as equiangular. Okay, irregular polygon, an irregular polygon has different measure of sides as well as angles. Here, this one, it is also having 5 sides. This figure is of 5 sides. This figure is also 5 sides, but it is a regular polygon because each side is equal, and here this side is not equal to this side. It is a irregular polygon. And same is the case with a rectangle. 2 sides are equal, opposite sides are equal, but all sides are not equal. That is why we are saying that this rectangle, it is an irregular polygon. Okay. Next, angle sum property. Angle sum property of polygon. Angle sum property of polygons. So, sum of interior angles of polygon can be calculated by the formula number of sides minus 2 into 180. Let's take an example. Here, a triangle. Number of sides is a triangle. Number of sides is 3. So angle sum is number of sides minus 3 minus 2 into 180. 3 minus 2 is 1. 1 into 180, that is 180. So we are saying that the sum of angles, we are talking about the interior angles. Sum of angles of a triangle is equal to 180. So if we have a quadrilateral, what is the number of sides? 4. Okay. Then angle sum 4 minus 2 is 2 into 180. That is equal to 360. Okay. In case of pentagon, we have 5 sides. Okay. 5 minus 2, that is 3. 3 into 180, or that becomes 540. Okay, so we can say in a pentagon, the sum of interior angles is always 540. And in case of hexagon, number of sides is 6. Angle sum 6 minus 2, that is 4. 4 into 180, that is 720. So this is the formula. If you can keep on going, if you take heptagon, likewise you can calculate the angle sum property of octagon, anagon, and decagon. Okay, so let's take an example here. So these are 4 questions rather, and in case of this one, it is a quadrilateral. We have to find this unknown angle. We know in a quadrilateral the sum of sum of interior angles is always equal to 360. So can you calculate this angle? Yes, you can calculate. You simply calculate, because we know this x unknown angle plus 120, okay, plus 130, this angle plus 150. This is all equal to 360. Okay, 360. Then you add these 120 plus 130 plus 130, 150, and we can easily calculate angle x by using this equation. And likewise here, in the next, here we have angle 70, 60, this is x, and it's not given also, because the sum of on a plane, when we draw a perpendicular here, if it is 90, the internal angle also will be 90. So it is not given, but it is also 90 degree. So we can easily calculate 90 plus 60 plus 70 plus x, it is equal to 360. 360. Then we can easily calculate the value of x. Okay. If we'll take the case of this, it is 70. This 70 plus this unknown angle, the sum of these two angles is 180, because at the linear pair, sum of interior angle plus exterior angle of any polygon is equal to, they are supplementary, that means the sum is 180. If it is 70, then it must be 110. Okay. If it is 60, then this angle must be 120. So we easily get these two angles. Now this is x, this is x. So how can we calculate the unknown angle x? We can say, how many sides is here? 1, 2, 3, 4, 5. So it is a pentagon. So we can say x plus 110 plus 120 plus 30 plus 30. So what is equal to, in a pentagon, what is the sum of angles? That is equal to sum of 500. Okay, you can easily calculate what is number of sides? Number of sides is 5. So 5 minus 2. What is 5 minus 2? That is 3. 3 into 180. That is equal to 540. 540. So this is equal to 540. 540, because it has 5 sides. So we can easily calculate x plus x. It is 2x plus 100, 200, 300, 60 is equal to 540. Okay. So 2x, when we transform this equation, it is 540 minus 360. Okay, 360. So 540 minus 360, what is equal to 140 minus 360? 540 minus 360, that is equal to 180. Okay, 180. So x is equal to 180 divided by 2. That's equal to x equal to 90. Okay. So likewise, in this last figure, we can calculate easily all angles. How many angles? 5 angles. Means 5 times x is equal to 540. 540, because it is a regular polygon. All angles are equal. So if this is x, this will be also x. This will be also x. So we can easily calculate the value of x. It is equal to 540 divided by 5. Okay, divided by 5. So what is the value of x? You can easily calculate x equal to 540 divided by 5. 540 divided by 5. That is 108. So each angle of this figure will be of 108 measure. Okay. So when we look at the exercise that is coming next, exercise 3.1, we will calculate. We will do the exercise one by one, each and every question. Okay. So the next is we have also learned that for a polygon, interior angle plus exterior angle is equal to 180. So this, if it is the value of, if it's the x angle and is x, it is y, x plus y is equal to 180, because these are the linear pair angles. Okay. Okay. So after that, we have what is the sum of exterior angles of a polygon is always equal to 360. It is one of the property of the polygons. If we have any polygon, if it is triangle, if it is quadrilateral, if it is, no doubt, the sum of internal angles we can calculate by the formulas. Number of sides is minus 2 into 180. But what about the exterior angles? These angles, these are the, if I will show you, these are the interior angles. These are the interior angles. So what about the exterior angles? If we are going to extend this line segment, we will get an exterior angle. So you have to simply remember that the sum of exterior angles of any polygon, whether it is triangle, whether it is quadrilateral, whether it is pentagon, hexagon, heptagon, any polygon, sum of exterior angles is always equal to 360. Here is an example. We have to find the measure of x. So all here we have a quadrilateral. This extra angle is 90, this is 50, this is 110, and this is x. So x plus 90 plus 50 plus 110 is always equal to. Why? Because sum of extra angles of polygon is always equal to 360. So x plus 90 plus 50 plus 110, that is equal to 250, is equal to 360. We can easily transform x equal to 360 minus 250, that is equal to 110. So we have easily calculated this angle, this unknown angle. Okay. Hope you have got it. And this is all for today. Thank you for watching. Please subscribe my channel, and I'm going to upload more videos, and inshallah in tomorrow's video we will do exercise 3.1, and till then be happy, take care, stay home, stay safe.